And welcome to Ladyada.
Hey everybody, welcome to Ladyada. I hope everyone had a great CircuitPython day on Friday. I know we did. Show and tell was amazing. I know there were talks and events and codes and sprints and more and more and more. Mr. Ladyada, do we have any updates, things? Just tell people go to Silicon? SJ,
no, we did all that.
You know that.
We did all that. We're just going to jump right into Desk Ladyada this week.
Okay.
Ladyada, what is on your desk this week?
You're here for the electronics, and so am I. So let's get into it. Okay, so last week we talked about light sensors, and one of the things I was talking about doing was designing a circuit playground with an RP2040, which doesn't have a lot of analog inputs, and so I wanted to replace the analog sensor, the analog light sensor, with the LTR 329, which I think I showed off. So let's just bump really quickly to the compy, and I can just show this off real fast. So this is the sensor that we found because it's a really good price. It's, like 20 cents. I2C sensor, and it's in stock. I love things that are in stock right now. So I got some I got some of those sensors in hand, and one of the things that is like my favorite thing in the world is when a sensor has the same footprint as another sensor, because it means I don't have to design a new board. Because the designing of the hardware, it doesn't take a long time to design the hardware, but it does take a long time to order the PCB and get it back and get all the parts, and you place it by hand. So one of the cool things is that as I was working on this, I noticed that this had the same footprint as the GUV. This sensor, it's made by a different company, but just coincidentally, it's got that same 4-pin package. And so what's neat is I can go to the overhead real fast. I can show this off. We'll zoom in too, because these are small parts. Okay, so this is, you can kind of see behind the Sharpie, it was a GUV sensor, and I just hot aired the old sensor off, and I put that LTR 329 on, and not only is the package the same, but the pins were the same. Again, total weirdo coincidence, I think, because it's a totally different company. Oftentimes when it's the same company, you will see, they try not to change. They try to keep the footprints the same because it makes everybody's lives a lot easier. So, if you've used the VL53 series of distance sensors from ST, there's the VL53 and VL53LC4 and the VL54-5, whatever. There's five or six different chips, but they all have the same pinout in the same package. Ditto with a lot of sensors. We've seen sensors the same, like the BMP280, the BME280, the BME680. All they're a little bit bigger or smaller, but the pads are the same, and so it actually makes, if I remember correctly, so it just makes it a little easier to use those sensors all together. Maybe BMP280, the BME280, and I think maybe the BME, whatever, 388, I don't remember. But they're all very similar. Anyways, so I popped this on, and then let's go back to the computer. And I wrote a quick driver for it. It lives here, LTR 329. Again, one of the things I've been doing lately is I've been writing my drivers in Python using a FT232H as an I2C converter, and then I tested on hardware, but the rapid coding I do on a computer, and it's because it's so much easier to debug, and it's quick. I can see I2C traces. It's easier to print stuff out than Arduino, where every time you do something you have to recompile. So I do save. I can write a driver in a couple hours. It's much faster. And it's just you can just create an array, and the array is created, and you don't have to worry about it. Memory's managed for you. It's kind of a blessing. Of course, it uses more memory, but it runs on a computer. I learned a couple things about the ALS 329. So hold on, let's go back to. Oh wait, actually, I have the driver here. So the 329 is it's very simple. It only has 4 pins. It has 2 diodes. One is visible plus IR, and one is IR. The only thing that's a little bit interesting about the sensor is you really have to read those 2 at the same time in one I2C transaction, the way the like data ready bit works is it's expecting you to read both at the same time. So I kind of had to like mess with the driver a little bit and the examples to make it clear that if you're going to use the data ready bit, because when you read it, it clears, and if it like happens to go, like if you're reading the two I squared C transactions, you know, eventually the interrupt comes in between and you end up clearing it. You don't realize you've cleared it. It's just a detail. But yeah, otherwise this was, you know, pretty easy sensor to get going. And then I'll just plug it into my FT232 here. So I got my board, and I have the simple test, and you know, it's just hold on, move to the side here so you can see. Yeah, I just got data coming out. One thing that is interesting is you know, you can overwhelm the sensor, although I don't. Yeah, you can see like visible gets negative. You can overwhelm the sensor, and there's another bit for data valid. Like if it overflows, like you can test the bit. So the advanced example does all that, like the data validity. Whoops. This seems to happen when my cable's not plugged in all the way. Hold on. There you go. So yeah, the data, there's a couple like cool bits and stuff. So it's a good sensor. One thing that is nice is it does IR as well as visible. And I was talking to Mr. Ladyada. We were out having lunch, and while we were walking to lunch, I was like, oh, you know, one of the cool things is because it has visible and infrared, I could put an IR LED, you know, somewhere on the board and then use this as a distance sensor. Not a great distance sensor, but you know, IR is way better than light because light is affected by ambient light a lot more, whereas you know, infrared is not. Now, the only thing is you can't do PWM infrared, which is like the right way to do like the pulses, but I'm willing to try it, see how it goes. So there's that sensor. And then while I was here, you know, I also looked at, if you remember, I also looked at the big sister, which is the LTR 303. And this sensor is very similar to the LTR 329. So it's a couple cents more, but it has 6 pins and it has an interrupt pin, which is like, you know, otherwise it's actually interesting. The register map is the same. It just has like this interrupt pin. And the package is slightly different. Let me see if I can find a photo of the package. Yeah, it's got six pads instead of 4. But again, you know, I was kind of like, you know, I wonder if it has the same package as the LTR 390, you know, which is it's a UV only sensor, but it's very similar. It's a 6-pin light sensor, and it turns out that yes, it has the exact same pinout. And so, let's go to the overhead. I took an LTR. I just did this right before the show. I took an LTR 390 and I hot aired the old sensor off, and then I plugged the new sensor in. And again, the register maps are the same. And so when I run it, I actually I get data out of this just the same. So all I have to do is update the library to add interrupt functionality, and basically the driver will be done. So I got, you know, these two sensors going, and then I also, while I was at it, I was like, well, I might as well get this this Groove B or Groove A sensor, this I squared C UV sensor that I designed like months and months ago. So I got this going, and you know, it's an interesting sensor. It's from Genicom, and like they make, you know, they're like a Korean company. They don't make a lot of stuff. They do make these sensors, and they work. I'll say the data sheet is a little bit like challenging. There's a couple different versions. Some of them are missing data, like some of them are like to be determined. I eventually did find enough data to get UV information from it. There's a calculation also for doing UV index from UVA or UVB, but we took it out. There was a little video where we we'll post probably tomorrow or the next day, where we went out to the park, and I had it on this feather, and I have it printing out the UV raw data and the UV index, and like the index went up to like, it was like 15, like it was really sunny out, but it wasn't UV index 15. So I got to figure out what's up with the calculation. This is kind of like what I do. It's like, you know, what's the difference between like Adafruit drivers and other drivers? It's like, I'll actually like email the company and try to get an answer and a data sheet and example code, and I'll make the library do the right thing. Because I found some people who tried to do the index calculation, I don't think they did it right. So, whatever. But hopefully I'll be able to figure that out. If not, the data, the raw count data is good. And it comes in UVA and UVB versions. So it's meant for scientific, or outdoor measurements. I'd love to have a UVC sensor. UVC sensors are hard to get. They tend to be a lot more expensive, and I haven't found one yet that is I2C, and that just does a UVC band. But, that's cool. So there's a lot of light sensors this week. And then I also wrapped up the tester for the Max 17048. Y'all remember 2 weeks ago, I talked about this chip because the LC 709203 battery monitor fuel gauge that we've been using is it's not discontinued, but they're kind of like slowly getting rid of it, or it's end of line, and we can still get it, but eventually that's going to end. Even though I've found that some parts are easier to get these days, I need to have an alternative, and this is a fairly inexpensive alternative. It's like about $1 a piece, maybe a little bit less. It's very low power. What's neat is that the pinout of the breakout board and the size of the breakout is exactly the same because it's pretty much the same. So this tester is actually designed for the LC 709, but I just swapped it out with this breakout, updated the code, and it does a quick test. It just verifies it can read the analog voltage here. This is from the 3.3 volt line. I2C works. I check the interrupt and the quick start pin, and if that's good, then it beeps. So this tester means probably be fabbing this week, which is very exciting. Okay, I think that's all of my updates.
All right, let's do a question, and then we'll do Great Search.
Cool.
So the question is, I know you haven't done anything with the smaller NRF52 chips, but what would you recommend to do when trying to cope with the NRF soft device hex being bigger than the flash on the chip? I've tried smaller soft device files, but I'm not sure how to proceed.
Yeah, I have no idea. You're kind of on your own. I mean, if you're not using, if you're using the much smaller boards or smaller chips, you need to use Nordic's SDK. They designed it specifically for their stuff. They're going to have code and examples. One of the things that we have to kind of remind people is we write code and we can test on our hardware. If we don't sell the hardware, we don't test it. So there's no real way for us to know if it works or if it doesn't work or how to fix it. So you're in uncharted forests or waters or exploring new lands. But Nordic does have really good tech support. I'm sure they'll be able to help you.
All right, let's do Great Search.
Okay.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by Adafruit and DigiKey. Thanks, DigiKey. Every single week, Ladyada uses her powers of engineering to help you find parts that you're looking for on digikey.com. Ladyada, what is this week's Great Search?
I'm glad you asked. I'm pulling it up right now. So this week's Great Search, you'll never believe it. It's a part that's no longer available. But I wanted to use this sort of as an excuse to look into and research a class of sensors that is near and dear to my heart. But it's always kind of like funky learning about them, which is gas and volatile organic compound sensors. So the board that we've been making, we can maybe go to the computer, is the CCS 811. This is actually one of the first, low-cost I2C gas sensors available. There are gas sensors that are analog. Let's see, there's quite a few gas sensors. There's like this. This is the traditional kind of gas sensor. It's an analog output. You have to turn on the heater and you have to kind of do a little bit of management and then read it. What's nice is that since these sensors are quite good, and this is how you measure gases. Depending on how the sensor is doped, it can measure I think carbon monoxide and alcohols and ethanes, and usually they mix a whole like nitrogen oxides, whatever. They usually can sense a whole bunch of things at once. Give you an analog output, and then they have to be calibrated. But for a lot of people, they just want to measure like air quality, like, you know, is there alcohol or gas in the area? This is different than carbon dioxide sensors, which are also gas sensors, but they usually use a different methodology. We have a couple CO2 sensors. The good ones that I really like are the SCD30 and the SCD40. The SCD30 is, you know, an amazing gas sensor. It has you know, an NDIR sensor tube, and it's like really well calibrated, and they're very, very good sensors, and they're true CO2 sensors. Most other sensors are kind of, they guess the CO2 based on volatile organic compounds. So, hold on, let me go back. So usually when you do, gas, you know, a sensor like the, you know, SGP30, for example, it'll say volatile organic compounds and FeCO2, effective CO2. So it's kind of trying to calculate the CO2 based on the volatile organic compounds. It's not true, but it does a fairly good job. But, you know, these are usually used, you know, air quality sensors indoor and outdoor, not particulate, but for gases. Also lots of scientific use cases as well. But so as I mentioned, the CCS 811 was a classic one. One of the first ones. People rather liked it. But and we kind of, for now, we recommend the SGP30, which is a pretty good sensor as an alternative. It's no longer manufactured. So, you know, there is an alternative for this chip. The, hold on. They recommend substitutes. They recommend the ENS 160, which I think is made by the same company, which is also a great sensor. The bad news is that you're like, when am I going to get some? And it's like, you know, like, Happy New Year 2023. Which, you know what, and I'm happy. I will, when that happens, I will probably pick some up, and we'll make a breakout for this, and all's good. But I wanted to find another gas sensor maybe in the meantime, while I wait for this to pop into stock. So let's go to the gas sensor category. And I'm also, you know, it's interesting. I'm not looking for direct replacement. I'm just kind of like seeing like what's up in this category. So it's still kind of like a little vague. I'm going to look for active designs only, because that's where I'm at. And, you know, I'm not actively looking again. I have other gas sensors. So I want something that's normally stocking. It doesn't have to be, you know, in stock today. One thing that I did notice, I just sorted by, you know, quantity available, is a bunch of CO2 sensors popped up, which is fine, but I don't want CO2 sensors. Those are, again, they're kind of different than air quality sensors. So I selected everything, and then I unselected carbon dioxide. That got me to about 200 things. So a couple good things. So, you know, the SGP40, this is a sensor that I've used. It's kind of the next gen of the SGP30. It's a good sensor. You know, you can get data out of it. It does have this kind of secondary library that you need to use to actually do some calculations. That's not unusual. There's also apparently the SGP41, which I didn't know about, so I'm actually going to check this out, because I'm assuming this is just some improved version of the SGP40. There's the SCD40 CO2 sensor, which still made it through. And then there's this kind of interesting, the Z-mods. What's interesting is I'd heard of these, but, you know, I'm kind of fascinated whenever I see something with 25,000 pieces in stock at DigiKey, because it's kind of like, oh, this must be like somewhat popular, because they would not stock that many of something if it wasn't. And so I was kind of like interested in looking at this a little bit more, so I'll do that in a moment. And there's a couple in that family as well. And then, like you see, there's the ZMod 4450, 4510, you know, A version, B version. So there's a couple of these. There's the SEN 50, which actually contains an SGP41. We covered this on INPI earlier. But really, it looks like the Z-mods are kind of like taken over. Like, there's the SGPs and there's the SCDs, but these are the most interesting. So what's cool about these is they're from Renaissance, who does make sensors and such. Let's see if we can load up the data sheet. If not, I will. I'll just go to the. Okay, so it's outdoor air quality sensor platform. So what's interesting about this sensor is for interfacing, at least it's I2C. So that's kind of good. I like to see that. Like, I don't like it when it's like, hey, we came up with some weird ass interface. I2C is pretty standard. Not worried about being able to communicate with it. The interesting thing is it does various measurements. Looks like it measures like nitrogen dioxide, ozone, air quality. It's got, it's a MOX resistant sensor like all of these are. And one of the things about MOX sensors, I will say just because, now I've used them a couple times, is like that analog sensor I showed you earlier, there's not a lot going on with these. Like, they are pretty much all made the same way. There's a few patents that expired probably, and so people are making more of them. But like, the concept is the same. Like, once you kind of dope it, you get this gas resistance, and you have to calibrate it a little bit. You have to normalize it, but you pretty much are just tracking this resistance and trying to convert that into, a semi-calibrated output of what the air quality is. So there's good news and bad news about that. One, good news is that, technically once the patents expire and people know how to make these, it's not too difficult to just manufacture these gas sensors. The problem is that there is, as an outsider looking in, it seems like because the technology is quite simple, like, not simple, but it's, you're just getting resistance value, and then, you track that and do with whatever you need to with it. The firmware, the stuff that actually reads that resistance and calculates that into something, is usually either baked into the chip, like the SGP30, or for more complicated stuff, it's kind of this external processor. And it reminds me a little bit of 9DOF sensors or 6DOF sensors where, you get accelerometer and gyro data or magnetometer data, but then you have to fusion it together, and that's where intellectual property kind of comes in and becomes a firmware issue. So, I looked into this, and it's an interesting chip, but here's the deal. The data sheet is actually kind of empty. There's like really, usually you open a data sheet, it's like registers and pins and bits and all that. There's kind of nothing here. They always have this like standard I2C diagram, and it's like, if you've never heard of I2C before, like, you read all about it, and they always are like, hey, there's a stop bit. It's like, yeah, cool. But then there's nothing after that, because what you're expected to do is you have to submit a request to get the firmware, and the firmware comes as a binary blob that you then link in with your application. So they have binaries for like the most popular platforms like ARM Cortex M0s and Espressif chips. You don't get to see the code. You feed it. You feed it the data, and out pops this algorithmic thing. It also reminds me a little bit of capacitive touch. Like Microchip does the same thing with QTouch. Capacitive touch is just a capacitive read. There's not a lot going on. There's a couple different ways of doing the waveform, but for the most part, you're reading capacitive data, and it floats around, and then it spikes and it goes down. So the intellectual property is how you filter that data, and they'd want to control that. And so, these days, when you get QTouch, it's not on the chip giving you raw data. Instead, you have to, you can get the raw data sometimes, but they sort of hide that. Instead, you're supposed to use this binary interface. So, it's interesting seeing how sensors have changed. One thing I do like about Sensirion is they don't have that. Like, when you use their sensors, they really do pop out in I2C. Whatever data you need, it's there. It's like CO2 level, you read the register, you do a little bit of like shifting math or whatever, out pops the number. With these sensors, it is a little bit less expensive. You'll see it's like, $350 instead of $510 or whatever. but in exchange, what they do is they don't have a powerful processor on the chip. You have to use this binary blob instead. So, it's interesting, especially for people who are used to temperature, humidity sensors that are just very simplistic in their functionality, to sensors that really are mostly a front end to a firmware processing system. And you need, I don't think that, maybe they have a library for AVR 8-bit, but, they probably kind of require Cortex M0 to do a lot of this calculation. And it's, of course, under NDA. So, it's interesting. I'm going to take a look at this chip, and, maybe I can see if they've released a library that I can use, because it's going to be tough for me to write a library when the firmware is under NDA. But we'll see what's possible. So this is the Zmod 4510. I guess this is the new way of this sensor. So folks gotta get used to it.
That's a great search.
Where in the world is that part I need? The great search with DigiKey.
All right.
Okay.
That's our show for tonight. I'm looking around to make sure there's nothing we gotta take care of. No.
Questions?
We're all good. I'm gonna get us out. See
Okay.
you throughout the week for a series of Adafruit shows. Thanks for spending your time with us. We very much appreciate it, and we'll see you around.
Bye, everybody.